just so you are prepared for what is coming up. All right, so the last thing we're going to cover in this section is, or in this chapter, is factorials, permutations, and combinations. So if you took statistics before, this should all be very familiar to you. It shouldn't be anything too difficult. So a factorial is the exclamation point, and it is used to represent the product of the first so many numbers. So there's always going to be a number in front of the exclamation point, and that is going to tell me my starting point and then what numbers that I'm going to multiply from there. So you always start at the number you have and you work your way all the way back to 1. So if we wanted to find 3 factorial, that is saying to take 3 times 2 times 1. So again, it's the product of the first however many numbers. So if it's 3, the first 3 numbers are 1, 2, and 3. So if I multiply that out, 3 factorial is 6. 7 factorial stands for what is the product of the first 7 numbers? So 1 to 7. Generally, I always write it from 7 down to 1 because I start with the number I have. 7 times 6 times 5 times 4 times 3 times 2 times 1. So if I do all of that multiplication, that is 5,040. Zero factorial is going to be 1. It's 10 factorial divided by 7 factorial. So what that's saying, long way written out. So 10 times 9 times 8 times 7, and then it's going to be 7, 6, 5, 4, all the way down to 1, right? If I stop here at 7 and leave the factorial symbol, it'll cancel out with the 7 factorial on bottom, right? If I didn't, it would be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 over 7, 6, 5, 4, 3, 2, 1. So I'm just trying to save you a little bit of writing here to see that 7 factorial is on both, so I can cancel that out. Because the same thing's happening here. 7, 6, 5s, 4s, 3s, 2s, and 1s cancel out. Leaving me still with that 10 times 9 times 8 for a final answer of 720. Factorials are used when we do permutations and combinations. So the first is a permutation. And a permutation is going to tell you the number of ways R objects can be arranged from N objects without repetition. So the way it's usually written is little n, capital P, little r. So you're going to write how many total objects you're working with. The P stands for I want to use permutation, and then R is how many of those objects I am taking. So if I wanted to find how many ways 10 horses finish in the top 3, well, that's 10 is my total N, and I want the top 3 positions. So R is 3. So I want to do 10 permutation 3. Now, there is a formula for this that we can follow. So the NPR permutation formula takes n factorial over n minus r factorial. So our total is 10. And then on bottom, you're going to subtract those. So 10 minus 3 is 7 factorial. This is why I showed you on the previous slide how to do 10 factorial over 7 factorial, because we just got that right here with this example. So that's going to give me 720. Now, that's not the only way I could have solved this problem. I could have said, because I'm arranging things, I have first place, second place, third place. If there's 10 horses, there's 10 potential options for first place. Once that horse is determined for first place, there's 9 remaining for second place. And once first and second place are taken, that leaves 8 remaining that could be in that third spot, which is that same 10 times 9 times 8, that same 720 that we got with the formula. We also have combinations. Now the wording is going to be similar, but slightly different. So the number of ways R objects can be grouped from n distinct objects. That's still, you're choosing R from n. The key is here, order doesn't matter. So in a case like this, it would be like, I want to put you in groups. It doesn't matter who I select first, second, and third. If Joey, Tommy, and Susie are the 3 chosen, they're in that group together. It's not a different group if I pick Tommy, Susan, then Joey. It's the same group of 3. So there's less choices or options when we do a combination. So this one's going to look like NCR, standing for combination instead of permutation. It also has a formula. N factorial is still going to be over n minus r factorial, but we're going to also put in there an r factorial. So there's an extra piece that we are dividing out to then get less outcomes. We are getting rid of all of the duplicate, triplicate, whatever we have, different arranged orders of the same grouping. So how many 3-person subcommittees can be made from 7 members? Key thing you're going to see as you're reading these. Are you arranging? Are you organizing? That's a permutation. Are you just grouping people together? That's a combination. So I want 3 of the 7. So 7C3. So we're going to start with 7 factorial on top. We're going to subtract them. That's 4 factorial. And then we also need r factorial, so 3 factorial. So I would write the top as 7 times 6 times 5 times 4 factorial, so that it can cancel out the 4 factorial on the bottom. And then write out my 3 times 2 times 1. So you're always going to get a similar thing to what we had in the permutation where something cancels out. You're then going to have extra pieces, though, from this extra r factorial that we're going to write here. Now, I know that 3 times 2 times 1 is 6, correct? So if I catch that, I can say, okay, well, that cancels out the 6. And now all I'm left with is 7 times 5, 35. Now, I also know that you all have access to scientific calculators. Desmos can do all of this for us. I will show you how we do that for the next ones here. Key is you just have to know, am I doing a combination or a permutation? So we have 6 here that we are going to do in Desmos. So if you want to write those down, and then you're just going to get the Desmos regular scientific calculator. The way we're going to do this is, so if you don't know how it works, you can go to function and you can see it right here. So NPR, NCR. So I can click this, and then it gives me parentheses to enter what is shown here, 8, 2. So 8, 2. And there's my answer. So I clicked function, And then I just found NPR. Other option, because you're on keyboard, is literally just type N capital PR and open parentheses, and it'll pull up that function. It recognizes it as well. So the second one is 7, 4. And then the third one is 10, 4. So NPR 10, 4. And again, this is just different texts write it different ways. So the way I wrote it was like 8P2. The way our book writes it is P8, 2. The way Desmos writes it is NPR parentheses 8, 2. Just depending on where you look, it's going to look slightly different. The key is the P is there. The larger number is always, the whole number is always the first number that you put. So whether it's written this way or 8P2, that whole number is always written first. I also have the combination function right here. So I could do that, 8, 2, or I could just type NCR and 7, 4. And I think it's also 10, 4. It's showing you that choosing the same numbers gives you less in combinations than it does in permutations. Feel free. You can use this. You can write it on a hand. For reference, I don't care which method you choose. I have 3 choices. And I have 3 examples. They will go one apiece. So we need to decide which one of these is a permutation, which one is a combination, and which one is neither. It's some other random scenario that doesn't lend itself to either of these two. So our options are the number of ways 8 people can stand in line for tickets, the number of ways letters can be assigned for a car license plate, and the number of ways students can be chosen to serve on a committee. But one of them is a permutation, one of them is a combination, and one of them is neither of the two. Key here is that a permutation and a combination cannot have any form of repeats. So is one of these options allow for repetition? Which one allows for repetition? Which one can have a repeated term? Yes. In a license plate, I could repeat the letter A 3 times. That's okay. So this is my neither. So in a situation where I can repeat something, it cannot be a permutation and it cannot be a combination, because that is not the case of the definitions. When I read them, it literally says the number of ways so many distinct objects can be arranged, right? Without that one says without repetition. This one says distinct objects. So they both mean the same thing. Nothing can be repeated. All right, so that leads. One of these order matters. One of them it does not. Order matters is the permutation. So which one is the permutation? The way you stand in line or the way you get chosen to serve on a committee? The way you stand in line is what matters for order. So permutation is going to be 7 and combo is going to be number 9. So again, there's 3 choices, 3 options. The number of ways students can be assigned offices on a committee. Now, this means specifically, so the offices means like you're assigning the president, the vice president, the secretary, and the treasurer. You're giving specific jobs to specific people. That is what that question is saying. the number of ways a 5-card hand can be dealt from a deck of cards, and the number of ways 9 students can register for a class. 11 is a combination. Why is it a combination? So we're drawing a group from the whole, right? I literally have a deck of cards and I'm reaching in and grabbing 5 cards out. Does it matter the order of the 5 cards that I get? No, I just want to pick 5 cards. Okay. Sometimes they're tricky. Which one has an order or a specific placement? Maybe that's not a good word. A little tricky. All right. 10 is actually our permutation. Okay. I don't really know. I don't have enough information to even be able to figure this out. For number 12, I mean, are they all registering for the same class or they're registering for a different class? Like, I don't really know. So 10 is going to be like your fill in the blank kind of a situation here where I've got a president, a VP, treasurer, and secretary. And if I have like 8 people that are running, there's 8 people to choose the president. Once the president is chosen, then there are 7 remaining for the vice president. And you can't take more than one position. So that one's going to be a permutation. 12 is our neither. Now we're going to actually solve a few of these. So it says, in a mathematics club, 8 people are running for the offices of president, vice president, and secretary/treasurer. So this is 1, 2, 3. So the secretary and treasurer is a single position. They're doing both roles. The student with the most votes will be the president. The student with the next highest votes will be vice president, and the student with the third highest votes will be the secretary or treasurer. How many ways can the offices be filled? So we already talked about this. This is going to be a permutation. We have 8 total people, and we are filling 3 slots. Okay, so I could either go to Desmos, or I could use my formula. The formula is 8 factorial over their subtraction. 8 minus 3 is 5 factorial. So 8, 7, 6, 5. I'm going to stop there because the 5's then cancel. And then 8 times 7 times 6 is 336. Number 14 says, how many ways can 10 people line up in the cafeteria line? Okay, I go to the cafeteria. I don't want there to be a line, right? I want to be the first person in line. So the position that I get matters to me. So that's a permutation. If I am the 10th person in line, I know that I'm going to have to stand there for probably a good 15 minutes. Not what I want. Now, 10 is our total, but it is also the number that we are arranging. So it is possible to, in fact, have the number I start with and the number at the end be the same number. That's just telling me that I'm arranging all of the objects that I have to work with. All right, so if I Desmos NPR 10, 10, there are 3,628,800 different ways in which I could line 10 people up in the cafeteria. Next one, how many ways can 7 people line up in the cafeteria line? Okay, no different than the one we just did, except for that instead of taking 10 people, we are taking 7. So I would open my Desmos again. I can find it. There we go. And nope, wrong one. NPR 7, 7, 5,040. How many ways can 5 people be chosen? There's your different word. Chosen from a group of 13 to attend a conference. So we want to choose 5 from 13. Means I have 13. I want to choose 5 of them. So I always just like to use this, especially with a combination, just because the combination formula is a little more involved. 1,287. Okay, how many ways can 3 oranges be chosen from a fruit bowl that contains 11 oranges? Again, keyword is chosen, so I'm doing a combination. I have 11, and I want to choose 3 of them. All right, so recap the formula if you came in a little bit late. That is total factorial. There's subtraction, so 11 minus 3 is 8 factorial, and then the second number factorial. So that would be 11, 10, 9, 8 factorial. I'm going to stop there to cancel out the 8 factorial on the bottom, and then 3 times 2 times 1. Okay, there's other like canceling you could do here. You could say, oh, 10 divided by 2 is 5. 9 divided by 3 is 3. And then I'm left with 15 times 11, 165. In a lottery game where 3 numbers are chosen from the set, so our numbers are 0 to 9, aka that is 10 digits. How many different 3-number cards could be made where order is taken into consideration? So order matters is permutations. I have 10 of them. I want to pick 3 of them. I would go to my calculator, we'll plug this in. You're going to get a lot more options than a combination. You're going to get 116,280. Versus, if order is not taken into consideration, there's your combination. 10, choose 3 is only going to be 4,845. Y'all just took me for what I said, huh? Nobody checked me. This should be 720. And this one should be 120. I apologize on that. In a lottery game where 4 numbers are chosen from the set of numbers 10 up to 29, how many different 4-number cards can be created when order is taken into consideration and order is not? So 10 to 29 is a total of 20 digits. So using order, 20 permute 4. No order is 20 combo 4, or 20 choose 4 is usually how I always say it. Choose for the C. So could I go back here? This one is the one that's 116,280 and 4,845. But always check my work. Questions on how we're doing this? Yeah. So permutation, you are arranging, you are ordering, there's a specific place, there's a specific job, position that you're taking. A combination is literally just you're making a group. So when I make a group of people, it doesn't matter who gets chosen first, you're still joining the same group of people. So that's where like those keywords you're going to see is like order matters or is arranged. That's permutation. If it just says you're choosing, combination. All right. So working with a deck of cards. A standard deck of cards is 52 cards. How many 5-card hands will contain the following? Well, first, let me just do this quick. How do we determine how many 5 card hands are possible? Well, there's 52 cards total, and I just want to grab 5. Right? So if I did 52 choose 5, there are 2,598,960 different 5-card hands. So like when you talk about the game poker, that's how many hands are available in a deck of cards. Okay? What I want to do is I want to get 4 jacks and 1 queen. How many jacks are in the deck of cards? 4. Yes, thank you. All right, so we have 4 jacks, and I want to choose all 4 of them. So 4, choose 4. Now, I'm separating this and 1 queen. And implies what operation? Or implies one operation and implies the other. Or is addition and is multiplication. All right, so there are 4 queens. I want to choose one of them. So because there's an and in between them, I'm going to multiply those 2 results. Okay, so on the side here, because I'm going to reuse these, so 4 choose 4 is 4 factorial over their difference is 0 factorial over, and then 4 factorial. 4 factorial, it cancels out, it's just 1. There's only one way, right? If I want to get all 4 jacks, there's only one way to grab all 4 jacks. Okay? 4 choose 1 is 4 factorial. Their difference is 3 factorial, 1 factorial. There we go. 4 times 3 factorial is going to cancel out the 3 factorial, and 1 factorial is just 1. So 4 divided by 1 is 4. So if I were to think about this, this should make sense, right? I have all 4 jacks, and then I can have the queen of hearts. I could have all 4 jacks, and then the queen of diamonds. All 4 jacks, the queen of spades, all 4 jacks, and the queen of clubs. There's no other groupings you can create, right? 4 is what I got. Now, some of these will have a little bit more, so I'm not going to talk about all the possible ways we could do it, but we can work through here. All right, I want to get 3 of the 4 jacks. So there's 4 jacks. I want to choose all 3 of them. And so multiply. I want to get 2 of the queens. So there's 4 queens total. I want to choose 2 of them. So 4 choose 3. So 4 is on top. Their difference is 1. And then 3 factorial. That's the same as 4 choose 1. These are identical. 4. Okay, so then I need to do 4 choose 2. So 4 factorial, 4 minus 2 is 2 factorial. Repeat what we're choosing, 2 factorial. So 4 times 3 times 2 factorial is going to cancel one of my 2 factorials. Well, that's going to leave me another 2 factorial, so 2 times 1. So let's see, that's 12 divided by 2, so that's going to give me 6. 4 times 6, 4 times 6. It's like I knew I forgot something. Thank you. It's 24. I'm not going to list all 24. Let's see. If I want 2 jacks and 3 queens, then I'm going to flip it. 4 choose 2 times 4 choose 3 is now going to be 6 times 4, still 24 options. If I want 1 jack and 4 queens, 4 choose 1 and 4 choose 4. That's basically A repeated, 4 times 1 or 4. Final question, how many 5-card hands contain only jacks and queens? I have used all of the options, right? I've used 4 jacks, 3 jacks, 2 jacks, 1 jack. I can't say no jacks because I'm drawing a total of 5 cards, right? And I want jacks and queens. So there has to be a combination of both of them. So 4 plus 24 plus 24 plus 4 makes a total of 56 of our 2.5 million only contain jacks and queens. So I'm going to show you this for now. You'll be able to do a part of it. We're going to talk about a basic probability on Thursday. But if you guys remember probability, you'd be able to start this now. This week is going to be a little bit different. You are going to find some game that you are familiar with, a board game, a card game, a dice game. Don't just say, I'm rolling a die. That's not a game, okay? Give me a game, all right? Say, like, I'm going to play the game Trouble, okay? The Trouble game has 1 die, and then ask your questions about that or whatever. So you need to tell me what game you are working with. You are going to create and solve a combination problem that you could create from your game. Create and solve a permutation problem from your game. Create and solve a basic probability from your game. Then, once you've done that part, then you're going to go find 2 of your classmates, their posts. So this is a discussion board, and you're going to go and check their work. So do you agree with their question being a combination question? Did they solve it correctly? Or do you think it needs to be done differently? So, for example, let's say I chose the game Monopoly. Have most of you played the game Monopoly? All right. So you know that you get property cards, right? So let's say I have 5 property cards and I want to know how many ways I could have chosen 5 of the property cards. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 property cards, not including, I'm not counting waterworks or, do I have to count the railroads? 22, so 23, 24, 25, 26, 27, 28 if I count everything. So 28 counting waterworks, electric company, and the 4 railroads. All right, so let's say I want 5 of them. I would say, okay, how many ways can I choose 5 of the property cards from the 28? Then I solve it. 28 choose 5 equals blah, blah, blah. Create and solve a permutation. Let's say I wanted those 5 cards in an exact order. I want to know how many ways, how many orders I can pick 5 property cards. Well, that's going to be 28p5, solve it. And then create a basic probability. So what is the probability I roll a 7 with my dice? Well, I can roll a 1 with a 6, a 2 with a 5, a 3 with a 4, a 4 with a 3, a 5 with a 2, a 6 with a 1. 6 ways out of 36, 1/6. So that's what I would write up, and then I would go find somebody else and say, yep, looks good. Oh, I think maybe, what about this? Maybe it's this way, or you solved it all right. Yay, you're awesome. Okay, so if you want to start working on that, you can. So basic probability is literally just a single question. What's the probability I draw an ace in my deck of cards? What is the probability I roll a 5? So that is some of the stuff we're going to talk about on Thursday. So sample space, basic probabilities of cards, dice, spinners, pairs of dice, all that kind of stuff.